Welcome to another video. In this video, we are tackling a challenge involving a wave equation. Write the equation for a sinusoidal wave traveling in the negative direction along an x-axis and having an amplitude of 0.010 meters, a frequency of 550 Hz, and a speed of 330 meters per second. Okay, so the equation of a sinusoidal wave, okay, traveling in the negative x direction is wave function, which is y, as a function of x distance, okay, that is distance traveled by the wave, then time t equals to amplitude sine parenthesis kx plus omega t. Now, this is because the wave moves left, and when the wave moves left, it means that the wave is shifting in the opposite direction of the x-axis. So when the wave moves right, it means that the sign in the equation will be negative, and that will be because the wave is not shifting in the opposite direction of the what? X-axis. So what I'm trying to say in essence is that when a wave travels in the negative x direction, okay, in the negative x direction, the sign, okay, the sign in the equation will be positive. That is, the sign of omega t in the equation will be positive, and that will be because the wave is shifting in the opposite direction of the what? Of the x-axis. Now, let's not forget that k is equals to 2 pi over lambda, and k is known as wave number, okay? Wave number is the number of waves per unit distance, and the unit of wave number is the radians per meters, okay? Then also omega, that is w, is known as the angular frequency, which is 2 pi f. Then this f is the what? Frequency of wave, which is the number of cycle made in 1 second. Okay, all right. So our goal, okay, is to write the equation for a sinusoidal wave traveling in the negative direction along an x-axis, okay, having an amplitude. So we're giving amplitude to be 0.010 meters, okay. We're also giving the frequency to be 550 hertz, and also we're giving the speed of the wave to be 330 meters per second. So the first thing, okay, the first thing to do is to first find the wavelength, because of course we have the equation model this way, that is wave function, which is y, as a function of distance x, and time t is equals to a, which is the amplitude, and we have the amplitude to be 0.010 meters, okay. And then k, we need the value of k. So to calculate the value of k, we need to first find the value of the wavelength, okay. So to calculate the value of wavelength, so let's say Roman numeral 1, wavelength. So for wavelength, okay, we know that from the equation connecting velocity of wave or speed of wave and wavelength, we have that v will be equals to f lambda. So if I make lambda the subject of the formula, I'm going to have lambda to be equals to v over f. So we have v to be 330 meters per second divided by frequency, which is 550, okay. So the unit of wavelength will be what? Meters in this case. All right, so in this case we're going to have, if I divide this by 11 and also divide this by 11, this will be 3, while this will be 5. So the wavelength will be 3/5 meters. So let's note this. All right, so Roman numeral 2. For Roman numeral 2, what I will do again is to, okay, now I'm going to calculate the value of k, okay, because like I said, we need to first find out or calculate the value of lambda, which is what we have here, okay. So for k, we have k to be equals to 2 pi over lambda. So k will be equals to 2 pi over lambda is 3/5. So this is 3/5, okay. Let's not forget that the unit of this is the what? The radians, number of waves per meters. Okay, so that K will be equals to, when this comes here, it becomes 5 times 2, that's 10. So we have 10 pi over 3, then radians per meters. So this is K. Okay, so next, the next thing now the next parameter to calculate is the what? Omega. That's why we are giving frequency, and the value of frequency is the 550 hertz. So Roman numeral 3. So we have omega, which is equals to 2 pi f. So then we have the frequency to be 550 hertz, so that W will be equals to 2 pi multiplied by 550. The unit of W is the radians per second, so that this will be W equals to 1100 pi radians per second. That is the angular frequency. Now, so now we can then substitute the values into the wave function equation. All right, that is the sinusoidal wave function. All right, so we have the general wave equation to be wave function as a function of, that's y as a function of distance x and time t equals to amplitude. Amplitude is 0.010 meters. Then sine parenthesis. Now, what is the value of K? We got K to be 10 pi over 3. So this is 10 pi over 3 times X, which is according to the equation, then plus WT. We have the value of W to be 1100 pi, then times T, which is the time taken. Now, let me factor out the common, let's bring out the common factor. So the wave function or the wave equation, the sinusoidal wave equation, will be y as a function of distance x and time t equals to 0.010 sine 10 pi, okay, open parenthesis, this will be x over 3, then plus 110 t. So this is the equation of a sinusoidal wave traveling in the negative direction along an x-axis when the amplitude of the wave is 0.010 meters and the frequency is 550 hertz, while the speed of the wave is 330 meters per second. Then the equation is what we have here. The noblest pleasure is the joy of understanding. Bye-bye.